to skip the ones that they've already hit, but I wanted to talk about the new device. So try to keep these at the table that I'm going to give them to you, otherwise we're going to get them just things and just kind of like hand out each one of these, and then you guys can just look at it, just like pass it around, see if you have a reference for what I'm going to talk about. And we won't talk for a while. Yeah, that's a big picture. Oh, you got it. Oh, cool. All right, sorry. Now, where did this come from? Okay. So, we're going to talk about the sort of design requirements on that device and what we did. First, if you're a hardware person, and Christina's a hardware person, if you go to our GitHub page, PhotoSync, just go to GitHub, search for PhotoSync, you'll see all of, everything's open source. So you will see the hardware, this is the actual circuit board files in KiCad. I know most of you understand this, some stuff, but for those who are, you will see all of the software repositories for the Android app, for the Chrome app, and for all the other components. You'll also see the case designs for this actual case and the beta case. So if you're interested in making modifications or getting stuff, go here first. If you can't find us, then just shoot us an email or something if you want to change things. And from here, there's a lot of reference material. Yeah, you can go check that out. So I wanted to walk through the components really quick. So we have a magnetometer, which measures the compass, accelerometer, which measures the leaf angle, contactless temperature sensor, and I'm going to break these all out.
I've looked at some of the data. You know, when we're making the measurements, they line it up before they plant, right? It's a leaf angle. That changes over the day. Really quite nice. It's what you would expect, but it's a really kind of fun thing.
Yeah, you learn a lot about the users.
No, it's not the user. I think the plants change.
Oh, I'm saying the plants.
I mean, it may be
both
target,
yeah.
but I don't know. I interpreted it as the plant,
You see biases and then you see actual effects.
Yeah, that's true as well.
Yeah.
But I think it probably could be real.
Yeah. Then this TCS sensor is the PAR sensor, which sits on top. That's the white thing. That's what's sitting underneath here, and it's actually the standard. You can go buy this on Adafruit. It's like a simple dollar charge for this TCS. We put some stuff on top of it to make it match actual PAR, or quality of PAR, but the sensor itself is very expensive. So that's the basic sensor list, and then we also have a holophonic sensor which measures magnetic field lines, which sits up here. So I'll show you. So that's the list of stuff. And you can see those parts. This is the contactless sensor. And if you want to look, you can kind of see the boards. It's just raw boards. They fit here and here. Here's this sort of stuff. I don't spend too much time on it because you guys are I just wanted to reference it. So, in terms of design requirements, what changed between the beta and now? That's quite the big question. So one, developed this new parameter, MultispeQ. So that's a parameter that wasn't measurable in 15 seconds. So the big design requirement was getting the most amount of data in the least amount of time, because as you know, most of your time is spent designing the experiment and getting it onto the plot, right? That takes you several hours. And then, you collect how many hours does it take to get to locations that you go to. So when you're there, you want to take as much data in as short a time as possible. And because of the type of data we collect, as Dave said, for instance, this data, you have to collect a lot of it anyway to be able to analyze it effectively. So in order to get the most data in the least amount of time, we added a whole bunch of sensors, which is the ones that I just described. We improved the signal quality so that this ECS trace, which we talked about, normally in the lab here, they do 7 to 8 measurements, which takes about 10 to 15 minutes. So it's because we improved the signal quality enough, we were able to do that in a single measurement, which means we can do it in half a second instead of 15 minutes. There was no other way we could have gotten the quantity of data. We hadn't have done that. That was a big piece. And then finally, this MPQT parameter, normally it's measurable in 10 to 15 minutes, and we method, I'm going to measure it in another 15 seconds. So all of those things are required to get the quantity of data that makes any of this stuff interesting. So most data at least on the time. And then scientific quality results without limitation, which was what Dave was talking about, right? We have things in here that are proven, like phi2, everybody can measure phi2 forever. And there are things in here that we're like, we haven't even tried it yet, we just included the sensor in case you wanted to mess around with it, right? We haven't thought, but we haven't tried it, like the temperature of the thermometer methods.
We didn't just do it haphazard.
No, I know.
We thought this was the most important thing.
But if we were LICOR, we never would do that, right? If we were a standard commercial producer, we wouldn't say, we threw this in there because we had an interesting idea that we had thought through.
We don't know if it worked yet.
Right. So we do sort of push the limits. As anybody who's used the betas knows, there's a lot of variation that comes actually just from compression. So if somebody has a beta that's, when you clamp the leaf, you're using your own thumb force to clamp, because there's a little bit of difference in how hard you press your thumb. You get differences in absorbances, and then you get differences in data. It seems like trivial, but it's not. And so with this, we have a spring that provides consistent clamping. That was one piece. We improved the detector circuit, which I talked about. We tested it thoroughly through the beta and then also through this. And then and then the last design requirement was it had to be application flexible. So we have people who want to do stuff with algae and cuvettes. So we made sure that it opens big enough to be able to fit a cuvette in it without taking it apart. In this one, we had to take it apart and add this component, which means that the calibration was lost, which means they had to calibrate it slightly. Then it goes in the drawer and everybody gets easy. So did that. It's also designed right now primarily to measure absorbance. So light on this side, detector on this side. But sometimes you want to measure reflectance, right? Maybe you're measuring, you're trying to measure anthocyanins in blueberries. You want to have the blueberry and measure reflectance instead of measuring through the blueberry. All you have to do is switch two detectors. So switch two detectors, and now all of a sudden you have reflectance at 8 wavelengths instead of absorbance at 8 wavelengths. And that allows you to do things like soils. Right? We've already done some interesting work with soil carbon, toxin, much good stuff. So if you're interested in reflectance-based stuff, you do. We made it easy to mask, which they referenced. We haven't built a mask for this, but I think we will make a stamp, a metal stamp that just fits over here. So it'll just fit over here, and then you can mask and have a very small 2 or 3 millimeter hole if you have tiny leaves. And you can get your absorbance measured on tiny leaves. Not probably still not. You need some other tricks for like pine needles. But people who measure like clover, like Friesen slab, tiny leaves, you need masks. So that's pretty easy to do here. And then finally, there's a USB connection on the back, which has all kinds of available pins. So what's inside this thing is an Arduino, it's a TNC 3.2, if you're familiar with that. And so you're just running standard Arduino. So if you want to call a pin and turn it high or turn it low, or set PWM to run a motor, if you want to control I2C, 16-bit ADC. Right, and Chris will show that, I think they have that in the algae one set up.
Yeah, I got it in my head set up.
Soil moisture probe?
Yes, those sorts of things, right? Especially if it's just a simple analog signal, like soil moisture probes, that's a piece of cake. So we made that to try to make it flexible so you can collect more data with this.
We need the holster though.
So anyway, we had a
Tribute, you know?
yes.
Well, no, that's my business model. I'm gonna that's how
Make the holsters.
I'm gonna make t-shirts and holsters.
Do like that. It's fair.
Because you haven't charged me for a photosync. What's it called? I just put this on my shirt.
Yeah, we're not.
We have a licensing fee.
We don't think we don't. Yeah, we don't have.
I'm just cheap.
So anyway, this is for the sort of hackers that make us take this device, take it apart, and connect it to it. And then finally, as you know, in the old device, you had to take the batteries out and charge them manually and put them back in. It didn't last all that long. On the new one, we got a dramatically bigger battery, which we feel is fairly heavy. It's internally rechargeable like your cell phone. You just plug it in and it charges. It's definitely still not waterproof. Don't like leave it out in the rain, but we attempted to do the best we could with it. So those are my 3 points I wanted to make. Application flexible, scientific quality results, and maximum data in a minimum amount of time. Those are the things we changed in the device in addition to the things that they already done. So, and then I'm sure you guys probably have a bunch of questions. So we're in the room, and then I just open it up for discussion. Does that sound good?
So how sensitive are the little light crystals or like stuff like honeydew? I was on a tree the other day, it was covered in aphids. And I was doing this and then I looked in there and the thing was aphids all stuck in there.
No, that's a good question.
Don't know.
Yeah, I don't know.
I think this goes back to the calibration. Once I calibrate the need for that and our desire to do that. I imagine if you clean it all pretty good,
Yeah.
let's say that over the day you accumulate dust and things, and some measurements are not going to be affected by that. For us, it shouldn't be. Some absorbances might.
And at that time, does someone have a look at mine, see if it's calibrated, see if it's...
Exactly. So, like having a card for SPAD or for other things, but also for the model conductance. We wanted to develop a little calibration, so like a little sheet of, like a tissue covered with a sheet of plastic and holds it in a specific conductance. Some think along those lines. How do you make sure that your device is calibrated to make these measurements?
I'm really interested in that. I had a chat with a uni the other day in Australia and they're measuring smoke conductance and I asked, can I come on site and do some measures at the same time that you're doing things?
Yeah. I mean, in general, I would say if it's something sticky, it's probably not the best idea. I think if it's like acidic or basic, over time, that will probably wear the acrylic because those are just acrylic guides. In a short term, it's not going to have a big effect, but in the long term, if it's got acidic stuff sitting on the surface.
This one fell out the other day.
Yeah, they do
And you
that.
could, if you have something that's fluorescent, let's say your
Right,
set
right.
fluoresces in the red where fluorescent. Again, I think we can develop a method to test whether or not it's a problem.
Well, honeydew, you get black soy mold after a while, and I have done some trees. Actually, I've got a tree that I can show you where I was measuring the tree last year and it was covered in black soy mold as well.
Yeah, it's going to be an interesting use case application. So, yeah. Go ahead, Mark. Did you have a question?
Just the USB-C is just wire out that directly continues. It's not a USB port.
So, yes, correct. We're using USB-C for just
Breakout.
And we chose that because USB-C is an open standard. HDMI is another one with lots of pins, but it's a closed standard. You can only use it for certain things that cost like $10,000 for license, which is nothing. But the problem with USB-C is that it's so new, no one even makes like the parts. Like we couldn't even get a cable that was fully, you could just get cables with power on ground. You can't even get a cable that have all the pins out. So yeah, it's kind of, also it's very hard to solder. Even this fancy place that we're getting it soldered couldn't solder pins.
Question about that, this certainly, because when you have is there any danger, I know this is the one for the power and the connection to the computer, is there any danger that people will put the wrong thing in there?
It so doesn't fit. You could try, but it just wouldn't.
Just curious whether you should like make a big more like.
Someone will make.
Yes.
And we don't do
But you'd have I don't, it's a good point, but I think they'd have a hard time, it won't connect basically, because they're fundamentally different sizes.
So does it tell us when it's low in battery? Because that's really
Yeah.
important, isn't it? Some of my data took with low battery.
Yeah. Well, now we cut the battery off before you should be to the point where it's effective.
Right.
So we just decided like, be safe and cut it off.
And can I plug an external battery in it? Will I charge it?
In theory you could, but you'd have to take it apart. I wouldn't. It's,
No, I put it in through the little micro USB.
Yeah.
We buy these things.
yeah, you could charge it through micro USB, you're right.
We should try that.
Yeah.
I've got one.
Have you got one?
Yeah, if you have a micro USB charger, that would be like as if it were connected to a computer.
Well, you get these things for your phone.
Or a battery pack, yep, that's the one,
What exactly?
this one, that
Yeah,
one,
no, that'll work.
that
For
works.
sure.
Sorry, I haven't used it before, so I mean, as a user, do you like wipe it down every time after you use it? But I was thinking of like plant diseases, so,
Yeah.
I mean,
I've done it once in a year.
yeah. Well, I just think that there are things that you possibly, that you might, I mean, mold is obviously something that you can see, but there's spores. I'm just curious, like, is it something that is a protocol for animals that?
This is an excellent point, something we've thought a little bit about, because in principle, you could be spreading diseases with rain, you do that. And so it'd be nice to have a partner who works in the disease field, who could tell, maybe we could develop a little protective layer, like, and see if that works.
Phytoclean.
There's like DNA or
I know.
things like that.
Phytoclean. You can have little phytoclean sachets. That's another marketing thing.
Yeah.
Yeah,
Need a marketing
so
department.
I think that there's lots of specific needs and methods that have to get developed for the different applications. And again, that's part of why I wanted to do this, because you all are from very different spaces, as you can tell. You're all doing completely different things. And so you're all going to have different methods about how you use the device. And I can't tell you what that is. We can sort of talk about it and how it is, but ultimately you'll know what's best for your application. And hopefully you share that with others so that standards start to develop.
The other thing about the cool thing about this, planning this community, that we can develop something really fast. If you were to ask Lycor, they're a great, just like, okay, we're really need this phytoclean thing.
And Phytoclean is actually a product.
But,
Yeah, no, it
oh,
is.
okay.
It kills
Just an example, what I'm saying is.
kills
It would
Phytophthora
take
and
a
other
long
area.
time, and they would be doing, they would probably be doing market research studies on it, find out whether it's profitable. And here we go, community, so you want that? Yeah, we'll try that, but you help us out with it. It happens so fast.
Okay, so that just occurred to me, so you're sending out different wavelengths, you send out, I'm sorry, I don't. like
No, go ahead.
UV?
Yeah.
Yes, it's UV, right?
We don't have UV, but they've
Because
set up
UV
UV in
kills,
there.
because UV is a DNA, it damages DNA, so you could just shine it through what's going on.
If you had a
Because you would
Uh,
Sorry.
So do you want to do UV or do you not want to?
UV is a sterilizer, basically.
Okay.
So you would no longer be carrying any solutions around.
Right.
Okay, interesting.
Sorry.
You cannot do that with this device.
Okay.
If you wanted to, you'd have to replace the light guides with the quartz. Then you could do it, it would be really good low cost because it would be in that region, about 260, 280 nanometers. But I would also say that if you got yourself a UV sterilizing like thing, it may damage over time the plastic, so you have to check it out. But kind of, on the other hand, they're so cheap that, you know,
Yeah, they're not bad. Just so to give you an understanding of what's in here, when you open the thing up, you see this light pad, this little, we call it a light pad, a light pipe or whatever, we call different things, but it's a little piece of plastic in there. And this took so long time because we wanted to keep this profile very thin, because I'm sure there's a Arabidopsis people here. You don't want to be digging into the dirt to get your little Arabidopsis leaves that are sitting just on the surface. Yours probably are similar, they just sit right on the surface of the dirt. So we try to make this profile thin. To do that, we had to have a long enough light pad so that the light going out was mixed when it got into the sample, but also wasn't lost. And also that the response coming back hit the detector with minimal loss. And that took forever to get this right. And so what we ended up with is this kind of periscope design where the light comes up, bounces off a little mirror, bounces off another mirror, and it goes out. And the signal comes back, but the detector actually sits right beneath this. So the signal doesn't have to bounce a bunch of times, and therefore we won't lose it. The light we can lose because we can always just turn it up higher. The signal we can't. And so that's why we designed it this way. So these are, they're actually, so we designed this way specifically because we can actually laser cut this part. If you take it and you turn it like this, it's just a laser cut. Which means we can make it out of standard acrylic, and we don't have to have a mold for it. Making a mold with clear acrylic is actually kind of a pain, but so that's it. Even though we took a big step up from that, where everything was 3D printed, we made it ourselves, we still are trying to keep things as simple as possible, even though they are, it's a step details.
So is it possible in the future that we could go and we could have CO2 sensors and multi-spec at the same time to save time?
Yeah, like in the USB, using the USB-C to get the information from the.
But what about your phone though? Because I can only access the app.
It would be on a single device. The USB-C would go to other stuff and collect data, but it would all be through a single connection.
Let me say something about that. We have the CO2 sensors in the beta. We don't have them here, but we have something better. As I said, we have that flow-through system for estimating. But you can also.
The soil.
Oh, yeah, okay. Well, okay.
Because that's a different, that'll be a different project.
It's actually, I mean, I would say that those devices are I2C, so you can hook them up.
Because this one's got the CO2 sensor in it, but I can only go and do the photosynthetic measures first, and then do my chamber measurements after. So every tree that I work on where I do the soil CO2, so it takes me like half an hour for each tree.
Why don't you just get two devices, one that does the CO2?
I want
Just
I
Dan.
want lots of devices.
Dan's been working on the one that's specifically for the soil CO2. And
It's
you
just
know,
when are they gonna be
soil
ready?
operation
and
chamber.
it's just,
They're pretty alpha
Can
prototype.
I take one of them home?
You can see it on Sunday.
I can bring it
Yeah,
to
you-
see where it's at.
And you can look at the data that we've produced so far.
Well, I'm keen to show you what, because I've got a tree where I've measured the soil biology before and after, and I've been measuring the CO2, soil CO2. So I know how the biology is improved, and it's incredible. And I've measured all the photosynthetic stuff at the same time as well. And I showed you the photo, like it's just like clear as day. October last year, it's nearly dead. This year, it's just powering. And we've collected all that. It's awesome.
Any other questions?
Can we go to the upper image?
So we're gonna use these so you'll get more from you.
Are you gonna be able to see the light pulses, like in the other one? You can see the light, like the
Oh,
red
yeah.
light and.
Actually, so we made the case thick enough so that the light doesn't intrude, which is a plus, but then you also can't see the light come out. So, it's sort of a bummer. I think that we addressed a lot of the connection issues though with beta on this one. And I guess Sean isn't here, but he could attest, he's taken a lot of measurements with both. It's quite a bit better. We spent a lot of time that you will never see and we will never get back.
Did you test different colours? Like, is white optimum, or obviously black is not a good choice? Which
Yeah.
I noticed your beta device was black.
Yeah, well, it was black because we didn't want light to get in and we didn't have a way to do it, so.
Have you tried different colours though? Like what about pink or red? Wouldn't that?
we want it
So-
to be as light as possible
Yeah.
to bring that
Reflect.
solar and heat producing without transmitting light that would interfere with what's going on outside.
Right.
When you make these dirt measurements for your net zero measurements, what is dark?
Which,
Well, and the temperature, you don't want it to heat up.
Yeah, you want it-
Because I've noticed on my measures
Yeah, exactly.
in Australia, like on a 35-degree day, you can see, like, after about my third measurement, it's useless. Because I can see that.
Spray painted them white. That's-
so let me show you, actually, here's an interesting, so this is leaf temperature differential, meaning the difference between the leaf temperature and the ambient temperature. And so you can see actually as light intensity goes up, that difference goes down. So the leaf is getting,
What does that mean, people? Tell me.
yeah.
This is important. This is really cool if this is right.
You see it on every project at
This
this point.
is what the drones and the satellites will measure from the temperature of the leaf. It indicates tomorrow conductance. Another way that gets tomorrow conductance, if it's right. So you're measuring the leaf temperature and the ambient temperature. It's actually a little bit more complicated. What you should have is a standard proof out. You should have a standard fake leaf, okay? But in principle, it needs this thermometer closed.
They also really should have ambient air temperature, shouldn't they?
We did, that's what I'm saying. This is the difference between ambient air and the leaf. That's what I just showed you. Now let me show you, I was trying to address your point. We see the same in our old data. You would see, you start at the beginning of the day and with the betas, and the temperature would just go like this, a little bit of like, as your hand would So here's the new one. Of the core, you know, so actually let's do it over time. Actually, I haven't seen this on being fair.
Isn't that leaf temperature? That's the temperature of the sensor, isn't it?
This is the air temperature.
This is ambient.
How did you measure air temperature?
This is temperature sensor.
In the device? But isn't there a difference between, like, if you've got if a healthy plant is really healthy, it's full of water, shouldn't the leaf temperature be lower than the ambient temperature?
If the transpiration is fluid.